Good day, it's Daniel Joseph Budlawan of BetSip STEM. Here we are the Group 3 together with Alberca, Dataro, De La Cruz, Reinco, Laman, Obumani, Quines, and Regula. We shall discuss to you the different memory elements. Starting off, what are memory elements? The memory, the computer data storage that lies in most computers as a given fundamental part. It is comprised of placeable and readable lists of data in cells that particularly hold one number. Knowing that a memory is comprised of cells, or memory cells, these cells store the numbers, and these binary numbers are secluded in groups. First of all, such binary number is called a bit, that may only either be a 1 or a 0. And a grouping of bits is called a byte, specifically a group of 8 bits. With two possible variations per bit, a byte can vary by 256 combinations within the 8 bits. In computers, memory cells in a memory is called a memory data, and it represents most of all the computer's processes. And some elements working with some of the memory cells that are responsible for reading and writing data in computers are registers, and such as processor registers act as a bridge between the main memory every time it is needed within each site. More of it would be discussed later in this video. After introducing an element, let us now know more about the memory element, the actual memory element. It is a device that at most can hold a piece of information, and with it there lies a common type of bit, which is a flip-flop, that may consist of some logic gates, such as either a NAND or a NOR gate loop, used to implement a clocking function depending on the type of the flip-flop. A flip-flop is the most common memory element in fast computer circuitry, knowing the output values is always saved and readily available when needed. Memory elements is the common to be working in hand with the computer memories. Together, they coexist within sequential circuits to perform computer processes. And with wrapping it up, memory elements are one of the smallest part of a system that has more than one stable state, given the data it represents. And now let's get more details with the types of memory element from our next reporters.
Good day everyone. Today I'm discussing the RS flip-flop. The RS flip-flop is used to store information temporarily until it is needed. A single RS flip-flop can hold one binary digit, either a 1 or 0. 4 RS flip-flop would be needed to store 4-digit binary number. So, ang RS flip-flop daw po ay ginagamit ito para mag-store ng mga pansamantalang impormasyon hanggang sa ito ay kailanganin. At ang isang RS flip-flop ay humahawak ng isang binary digit. Ito man ay 1 or 0. The picture below shows the standard sign for the RS flip-flop. The name comes from the inputs, which are called R for reset and S for set. It is sometimes called an SR latch. As was already said, the first output Q and the second output Q go together. The RS flip-flop has two output conditions. When the first Q output is high and the second Q output is low, the flip-flop is set. When first Q output is low or jump, the flips cannot be used in logic circuitry. So, ang RS flip-flop daw po ay may dalawang output condition. Ang una po is kapag yung first Q output po natin is high or 1. And yung second Q output natin is low or 0. Yung flip-flop po natin is set. Kapag naman po yung first Q output natin is low or jump, hindi po natin magagamit yung flip sa logic circuitry. So, ang pangalawang output condition naman po sa RS flip-flop is the jump condition is corrected when either S or R goes low. To reset, the opposite is required. S input low and R input high. So, ang pangalawang output condition sa RS flip-flop is yung jump condition ay matatama lang kapag alin man sa S or R ay magiging 0 or low. At time 0, both S and R are high. As a result, first Q output is low and second output Q is high. This is the jump state that can be used for logic circuitry at this end. Sa oras daw ng 0, parehas na S and R ay high or 1. So, ang result is first Q output natin is low or 0 and second Q output natin is high or 1. So, ito daw po yung jump state na hindi natin magagamit sa logic circuitry.
Good day everyone, my name is John Joris S. Dataro and I'll be reporting the clock RS flip-flop. So let's define what is the clock RS flip-flop. A clock RS flip-flop is a type of a sequential logic circuit that is commonly used in a digital electronics to store and manipulate binary data. Also said in our visual that a clock is an apparatus that regularly creates a signal that alternates between a high state 1 and a low 1 0. So computer processes are carried out in a systematic way. So thanks to clocks, they do this by making some process possible on only at times. A high pace and a low pace make up each cycle of time that clocks split in two. Clock cycle is specifically described as the span of time that start when the clock enters a high state, continues through the transition down to a low state, and concludes with the commencement of the transition back to the high state once more. So in other words, it is called a clock flip-flop because it uses clock signal to control when the data is stored and when it's output. So for this slide, clock RS flip-flop, you can see the period and clock cycle and its truth table. So first on the top right, first you can see here that every clock cycle has a own period. So on the first period, 1 is our high and follow with the 0 which is our low. So for the second period, it's also the same for the first period. So as well as to the other period, it came from our high na that is 1 and follow with the low 0. So ganun lang siya. So every period, nanggagaling siya sa 1 yung pinakamataas natin, yung high natin, then magka-follow siya sa low natin which is 0. So for our truth table, the flip-flop has a 2 inputs. So R for reset and S for set. When the R input is high and the S input is low, the output is reset to 0. When the S input is high and the R input is low, the output is set to 1. So when both inputs are low or both inputs are high, the output remains unchanged or no change. So here you can see our truth table. So here on the, you can see on the top of the table the S, R, C, and the two outputs. So yung S natin yung set, yung R for reset, and dalawa nating output. So you can see here the X for set, R for X. So no change yan. And for the 0, 0. So makita nyo na no change siya. So 0, 1. Ang outputs niya ay 0 and 1. So yung next one is 1, 0. Yung output niya is 1, 0 din. So yung set natin is 1. Ang reset natin ang and 1. So parehas siyang 1. So ang output natin dyan ay undefined. So, ang set natin is 0. Ang reset naman is 0. Ang output nito is unchanged or no change. So, yung set naman is 0. Ang reset is 1. Ang output is 0, 1. So, parang parehas lang siya sa kung ano nakalagay sa set and kung ano nakalagay sa reset. So, magkakaroon lang ng no change and undefined kapag parehas yung value ng set and reset natin. So, for the last example sa truth table is ang set natin is 1, ang reset natin is 1. So, ang result natin for the output is undefined. So, yun. Lastly, for the circuit diagram of clock RS flip-flop. So, coming from left side, you can notice the RCS, which are the R for reset, C for clock, or clock pulse, and S for set. For the other side naman is yung dalawang output natin. So, yung R and S ay nakakonect siya sa dalawang AND gate and follow with 2 OR gate. And lastly, nakakonect silang dalawa sa magkabilang dulo ng NOT gate natin. So, after NOT gate na yung dalawang output natin. So, the output of the flip-flop is clock with the clock signal. This means that the output only changes when the output signal transitions from low to high, called the rising edge of the clock. This allows the flip-flop to synchronize its output with the rest of the circuit and eliminates the possibility of unpredictable or unstable output. So, yun lang. That's all for my report. The next topic is D flip-flop.
Good day guys, my name is Kanajem Irregular and my discussion is all about a D flip-flop. D flip-flop. So what is a D flip-flop? A D or delay flip-flop is a digital electronic circuit used to delay the change of a state of its output signal, Q, until the next rising edge of a clock timing input signal occurs. So sa madaling salita, ang delay flip-flop ay isang digital electronic circuit na ginagamit upang mapadelay ang pagbabago ng ating state sa output signal. What is the D flip-flop used for? The D flip-flop acts as an electronic memory component since the output remains constant, unless deliberately changed by altering the state of the D input followed by a rising clock signal. So, sa ating nabasa, ang D flip-flop ay ginagamit. Ito ay ang D flip-flop ay nagsisilbing electronic memory component dahil ang ating output ay hindi nagbabago. Maliban na lang kung ito ay babaguhin sa pamamagitan ng pagbago ng ating D input. Where are D flip-flop used? The D flip-flop is a building block shift registers. For example, by cascading 8 D flip-flops in sequence, a byte, 8 bits of information can be stored after 8 clock cycles. So, sa ating pagkakabasa, ang D flip-flop daw ay isang building ng block shift registers. And sa example, sa pagkasunod-sunod ng pagbaba ng ating 8 D flip-flop, ang 8 bits of information ay maaring ma-store pagkatapos ng ating 8 cycles. What else can they be used for? They can be used for by connecting the intervening output of the D flip-flop to the D input. A simple divide by 2 circuit is created. The D output changes state at half the frequency of the clock signal. By cascading D flip-flops and through appropriate design of external combinational logic gates, a countdown timer can be created. And lumakad naman tayo sa ating nasunod na i-report, which is JK flip-flop na i-report naman ni De La Cruz.
Good day, I'm Jericho Branem De La Cruz and I'm here to discuss about the JK flip-flops. So, The JK flip-flop is one of the most used flip-flops in digital circuits. It is a universal flip-flop with two inputs, J and K. Now, the J and K are autonomous letters used to distinguish the flip-flop design from other types. So, meron din po tayong tinatawag na iba't ibang flip-flop types tulad ng SR. So, para ma-distinguish po natin ng JK flip-flop, gagamit po tayo ng ibang letters. And a JK flip-flop is a type of digital circuit that is commonly used for storage and transfer of data in electronic systems. Now, tinatawag po natin itong flip-flop because it can be in one of two stable states, just like a flip-flop sandal. Next, in JK flip-flop, there are no invalid states even if the J and K flip-flops are set to 1. Now, there are no invalid states in a JK flip-flop because ang inputs are designed to prevent them from occurring. In the JK flip-flop, the inputs J and K are used to control the state of the outputs Q and Q bar. So, may connection ang ating Q and Q bar sa ating J and K. Ang J and K ang magkocontrol ng ating output, which is ang ating Q and Q bar. If both inputs are high, meaning J is equals to 1 and K is equals to 1, the flip-flop will toggle or change state on the next clock pulse. Now, if both inputs are low, the flip-flop will hold its current state. If one input is high and the other is low, meaning J is 1 and K is 0 or vice versa, the flip-flop will set or reset to a specific state on the next clock pulse. In this case, the output Q will be the opposite of the input J, and the output Q bar will be the opposite of input K. So, makukonclude po natin na hindi possible for the both inputs to be high or low at the same time, which means that there are no invalid states in a JK flip-flop. The invalid or illegal output condition occurs when both inputs are set to 1 and are prevented by the addition of a clock input circuit. So, the JK flip-flop has 4 possible input combinations. Now, the two input AND gates of the gated SR table have now been replaced by two 3-input NAND gates, as we can see in the circuit, with the third input of each gate connected to the outputs at Q and Q bar. This cross-coupling of the SR flip-flop allows the previously invalid condition of S is equals to 1 and R is equals to 1 state to be used to produce a toggle action, as the two inputs are now interlocked. If the circuit is now set, the J input is inhibited by the 0 status of the Q through the lower NAND gate, and if the circuit is reset, the K input is inhibited by the 0 status of Q through the upper NAND gate. Now, when both inputs of JK flip-flop are set to 1 and clock input is also pulse high, then from the set state to a reset state, the circuit will be toggled. The JK flip-flop work as a T-type toggle flip-flop when both of its input are set to 1. So makikita po natin sa truth table that the JK flip-flop is called a flip-flop kasi nga meron siyang two stable states. Now, meron tayong outputs Q and Q bar as makikita natin sa truth table. And they are complementary, meaning when one is high, the other is low, and vice versa lang sila. The JK flip-flop can be in one of 4 possible states, as I mentioned earlier, depending on the values of the inputs J and K and the state of the outputs of Q and Q bar. Now, the 4 possible states are set. So, sa set, meron tayong ang Q natin is equals to 1 and ang Q bar natin is equals to 0. Now, if the input J is high and the input K is low, the flip-flop will be set to the set state on the next clock pulse. Now, the second possible state is the reset. Now, to have this condition, ang Q natin is 0 and ang Q bar natin is 1. Now, if the input J is low and the input K is high, the flip-flop will be set to the reset state on the next clock pulse. The next state is the toggle. So, ang Q natin is equals to 1 and ang Q bar natin is 0. Now, ang pinagkaiba niya sa set is both inputs are high. Then, the flip-flop will toggle or change state on the next clock pulse. And the last is hold. So, meron tayong hold which is Q is equals to Q or Q bar is equals to Q bar. Now, if both inputs are low, the flip-flop will hold its current state. Now, the JK flip-flop is a faster clock version of the SR flip-flop. Tulad nga ng sinabi natin kanina, minodify lang natin ang SR flip-flop. Gumamit tayo ng 2-3 input NAND gates at gumawa tayo ng cross-coupling sa ating SR flip-flop. And ito yung naging result, which is the JK flip-flop. Now, however, it still has a race problem. When the state of the output Q is changed before the clock input's timing pulse has time to go off, this problem occurs. To avoid this period, we must maintain a short timing plus period. So that's it for the JK flip-flop. Thank you.
So, good day, my name is Brandon Joshua M. Erinco, and today I will be discussing the T flip-flop. So, T flip-flop, dito makikita niyo yung applications na ginamit. So, itong T flip-flop is like a JK flip-flop. It is a universal flip-flop that makes the circuit toggle between two states and is widely used in shift registers, counters, PWM, and computer applications. So let's define first the T flip-flop. In T flip-flop, T defines the term toggle. So ay yung ibig sabihin ng T sa T flip-flop. In SR flip-flop, we provide only a single input called toggle or trigger input to avoid an intermediate state occurrence. Now, this flip-flop works as a toggle switch. So the next output state is changed with the complement of the present state output. This process is known as toggling. So, a T flip-flop is like a JK flip-flop na ang ginawa dito is pinag-combine lang ng T flip-flop yung JK flip-flop. So, this modified form of JK flip-flop is obtained by connecting both inputs J and K together. So these are basically a single input of JK flip-flop. So this flip-flop has only one input along with the clock input. So dito yun, ito yung J, ito yung K naman. Pinag-connect niya lang yung dalawang input. So next slide. We can construct the T flip-flop by making changes in the JK flip-flop. The T flip-flop has only one input, which is constructed by connecting the input of JK flip-flop. So ayun, tulad ng sinabi ko kanina, this single input is called T. In simple words, we can construct the T flip-flop by converting a JK flip-flop. Sometimes the T flip-flop is referred to as a single input JK flip-flop. So, block diagram of the T flip-flop is given where T defines the toggle input and CLK defines the clock signal input. So, ito yun. So, ito yung makikita nyo sa left side yung T flip-flop circuit. So, ito yung construction ng T flip-flop. The T flip-flop is designed by passing the N gates output as input to the NOR gate of the SR flip-flop. The inputs of the N gates, the present output state Q and its complement Q are sent back to each N gate. So the T flip-flop is formed using the D flip-flop. In D flip-flop, the output after performing the XOR operation of the T input with the output Q rev is passed as the D input. The logical circuit of the T flip-flop using the D flip-flop is given below. So, ito yun. So, next. So, there are the following two methods which are used to perform the T flip-flop. So, yung una is yung by connecting the output feedback to the input in SR flip-flops. So, pangalawa naman is yung we pass the output that we get after performing the XOR operation of T and Q prev output as the D input in the flip-flop. So, next slide is yung truth table para sa T flip-flop. So, pag yung T is 0, yung previous natin sa Q is 0 din. So, ang Q prev is magiging 1. So, ito yung inversion. So, sa next naman, ganun din. Q is 0 as yung Q complement is 1. So, kapag 0 ulit yung T, dito naman sa previous, Q is magiging 1, tas yung Q complement is 0. So, kabaliktaran lang yan ng sa Q. So, ganun din sa next. So, dito, pag 1 naman yung T, yung previous is magiging 0 and yung Q complement is kabaliktaran lang neto is magiging 1. Pero dito sa next is ang Q is magiging 1 at yung Q complement naman is magiging 0. So, sa last naman is kapag T is 1, yung previous Q is magiging 1, then complement ng 1, syempre 0. So, sa next is yung Q is magiging 0 naman, so Q complement is magiging 1. So, yun lang para sa truth table ng T flip-flop. So, next reporter, i-discuss yung registers.
Good day. My name is Romel Chavez Laman. Discussing about registers. So, meron tayong dalawang type ng registers na i-discuss today. Yung una is buffer register na i-discuss mamaya ni Luis. At yung ship register na i-discuss ko pagkatapos ng buffer registers. So, ito yung introduction ng registers. So, ano nga ba yung registers? So, ayun. A register is a device which is used to store such information. It is a group of flip-flop connected in a series used to store multiple bits of data. The information stored within these registers can be transferred with the help of shift registers. So, yung register daw, isa siyang device na pag, uh, pag-store ng mga information. Tsaka isa rin siyang group of flip-flops na magka-connected in a series. So, yun.
So ito yung buffer register, a binary word that is stored in a register type known as a buffer register. Since each flip-flop can hold a single bit, they can be built using a succession of them. This indicates that one must create an array of n flip-flops in order to store an n-bit binary word. So dito sa example 1, ang ginagamit dito is 4 positive edge-triggered D flip-flops cascaded together to generate a 4-bit synchronous buffer register. So, una muna is ano ba talaga yung buffer register? Ang buffer register is groups siya ng flip-flops that is used to store binary data since yung registers can store binary data. With the word buffer, it means that buffering is nothing, meaning when the input is 0, the output is also 0 for the buffer gate. And when the input is 1 for the buffer gate, the output is also 1. So in short, kung ano yung information na nabibigay, or nasabi ko yung earlier na kung ano yung input, yun din yung output. So dito sa example 1, kita nyo na may B1, B2, B3, sa B4. Nagre-represent yun as an output. So yung ginamit na flip-flop dito is D flip-flop and nag-act yung D flip-flop as a data flip-flop. Meron din dito yung Q1, Q2, sa Q3, and Q4 na nagre-represent as output naman. So ang nangyayari dito is kung ano yung data na nabibigay as input, yun din yung data na nagge-generate as output. So yung D1 to D4 is where the data is given. Tapos while collecting the data, dun magtatapos sa Q1 to Q4. So dito naman sa baba ng registers, makikita yung clock signal na tinatawag. connected siya sa lahat ng register, where sa next example is makikita on how buffer registers work. So we have here yung example number 2, where kung ano yung data na gusto nyong i-store. So for example, yung B1 to B4 is iba-iba yung input, except pala sa B1 sa B2. Since yung B1 sa B2 is the same input, 0, 1, 0, pero sa B3, sa B4, iba sila. Which yung input ng B3 is 0, 1, 0, 1. Ang B4 naman is 1, 0, 1, 0. So makikita nyo dito sa baba naman is yung Q1 to Q4 ang output ng B1 to B4. So kita nyo naman is kung ano yung in-input, yun din yung output. Since ang nangyayari nga dito is kung ano yung input, yun din yung data na ma-generate as output. So buffer registers don't allow for input control, which results in uncontrolled outputs. Controlled buffer registers can be used to get around this problem. So ano nga ba yung controlled buffer register? A controlled buffer register controlling loading inputs. It has a signal called the load signal. Its purpose is to store the data sa mga flip-flops, and it also has the same principle in a buffer register. But the difference is that may permission sa load to store data kasi ang load is nag-act siya as a superior sa register or as a instructor. So here naman is tri-state switches are utilized in this design to regulate how data is loaded into and or retrieved from the buffer register na makikita sa example 3 sa next slide. So here's sa example 3, we have the blue line sa red line. Yung blue line sa taas, which is the LD or WR, isa siyang control line na ang purpose is pag low in order siya to store the data na ini-input. So yung sa baba naman is yung red line, which is the RD. Isa din siyang control line. So ang purpose naman nito is dapat low yung data para mabasa ng switch. So basically yung tri-state switches, yun yung nagko-control din na halos kung gaano kababa yung mga data na ini-input para magkaroon ng output din dun na babasa. So ayun lang yung purpose ng tri-state switches.
Shift register. Shift register are sequential logic circuits that are used for conversion, storage, or transfer of binary data. These are used to convert between serial and parallel data. They can be used in data communication circuits as well as memory and buffer circuits. Many complex electronic circuits such as microprocessor and microcontrollers use shift registers internally. Serial in, parallel out, or what we call SIPO. It converts serial data parallel data. It is used in communication and to convert multiple input ports to serial data. So as we can see on our screen, the diagram. So the first flip-flop output is QE. It is connected to the second flip-flop input DB. The second flip-flop output QB is connected to the third flip-flop's input DC, and the third flip-flop output QC is connected to the fourth flip-flop input DD. Here sa ano po natin, yung QA, QB, QC, and QD, ito po yung ating outputs. So initially, all the outputs will become 0. So without CLK or clock pulse, all the data will become 0. So let's take a 4-bit data input example like 110. If we apply the first clock pulse 1 to the first flip-flop, the data to be entered in the FF or the flip-flop and QA becomes 1, and remaining all the outputs like QB, QC, and the QD will become 0. So ang ating first data output po natin is 1000. So if we apply the second clock pulse as 0 to the first flip-flop, then QA becomes 0, QB becomes 0, QC becomes 0, and QD becomes 0. So ang ating pangalawang data output will become 0100. dahil po dito sa shift right process. If we apply the third clock pulse as 1 to the first flip-flop, then QA becomes 1, QB becomes 0, QC becomes 1, and QD becomes 0. So the third data output will become 1011 due to the shift right process. If we apply the fourth clock pulse as 1 to the first flip-flop, then QA becomes 1, QB becomes 1, QC becomes 0, and QD becomes 1. So the third data output will become 1101 dahil po sa ating shift processing. Parallel in, parallel out, or PIPU are the type of storage devices in which both data loading as well as data retrieval processing occur in parallel mode. So ito pong PIPU register is simply utilized like a temporary storage device. So similar lang po siya sa ating i-discuss na CISO register. So nag-work po siya is like a parang delay element. So sa ating data which is given in parallel format to the parallel input pins like DA to D0, and after that shifted to the equivalent output pins from QA to QD. Once the shift register are clocked, one clock pulse is enough to load and one clock pulse is to unload to the temporary storage device. So as you can see sa ating screen, yan po yung ating diagram. So dito po is yung 4 input po natin, which is DA, DB, DC, and DD. Ayan po yung ating input sa ating flip-flops. So sa output naman po natin, ito po yung QA, QB, QC, and QD. So ito pong mga flip-flops na to is nakakonect lang po sila sa isang clock pulse. So kunwari meron po tayong data input na 1101 na nakaload sa ating nakaload sa each flip-flop. Initially the output will become 0 0 0 0, apat po na 0 kasi if we apply the first clock pulse 1, then the data will become shifted from input DA to QA. So the output will become 1101. So nagbalik lang po. So makikita po natin yan mamaya sa ating truth table. Parallel in, serial out, or PISO converts parallel data to serial data. It is used in communication and to convert multiple input ports to serial data. So in this parallel input serial output, or what we call PISO shift register circuit, is ginagamitan po natin siya ng logic gates. So one control signal or shift load is used to control the parallel input and serial output. So after that, NOT gate outputs are connected to G1, G2, and G3, and the other inputs G1, G2, and G3 are B, C, and D. Here A is directly connected to the A of the first flip-flop. The direct control signal is connected to one input of the G4, G5, and G6, and more input of the G4, G5, and G6 are connected to the outputs of flip-flops like QA, QB, and QC. The OR gate is connected to the second, third, and fourth flip-flops inputs like DB, DC, and DD. All the flip-flops are to be connected in a single clock pulse, and the following the flip-flops outputs will be in the serial data output. Now we are going to see how the data is loaded. Here we are choosing the input data is 1101, then A is equals to 1, B is equals to 1, C is equals to 0, and D is equals to 1. When the control signal applied to NOT gate is 0, then its OP will become 1, and G1, G2, and G3 will enable, and G4 and G5, G6 will disable. So all the inputs are loaded, and And after that, OR gates are also enabled. The data is to be loaded to the input of each flip-flop. So now we are applying control signal 1 to NOT gate. Then the output of this gate will become 0. Then G5, G6 are enabled. Once the clock pulse is applied to flip-flops, then the data will become 1101. So is shifted, may nangyari po ditong shifted to the right side from 1 or OR gate to the other. Serial in, serial out, or SISU. Shift register has a clock input, a data input, and a data output from the last stage. In general, the other stage outputs are not available, otherwise it would be a serial in, parallel out shift registers. So meron tayong example dito ng ating binary number, which is 1011. So bago tayo dumako doon, so yung circuit muna natin is magre-reset. So ang magiging output muna natin sa every register will be 0. So lahat is magiging 0, apat is magiging 0. So sa ating 4-bit shift register, example like may apat tayong 1 sa ating flip-flop. So the LSB bit is 1 and the MSB bit is 1. First, the high signal is LSB bit. Ginagamit ito as a input to the D3 flip-flop. So yung ating D3 is equals to 1. Then primarily all the D flip-flops outputs will be 0. So D2, D1, D0 is equals to 0. When D3 input is high signal, then D3 will cause Q3 to be 1. Therefore, overall output for first falling edge will become 1000. Similarly, when the next data input bit in the above 4-bit like high signal is given at the flip-flop D3, again D3 will cause Q3 to be 1, and Q3 is given as a input to F flip-flops D2. So in D2 will cause Q2 to be 1, when all the remaining outputs will become 0. As a result, we will obtain 1 1 for a second falling edge. So we will obtain 1 1 at the storage bit in the shift register. So overall, sa ating output for the second falling edge will get the output of 1100. Makikita po natin mamaya sa ating truth table. So sa pangatlong input natin, pangatlong input bit like high signal, i-applied po natin siya sa D3 flip-flop. Then earlier Q2 output will cause D1 input to be 0. This will give the output Q3, Q2, and Q1 as 1, whereas Q0 will be 0. So the overall output natin for the third falling edge will get an output as 1110. So in addition, an MSB bit like high signal is given as input. After that, 1 at Q1 will cause D0 to be 1. So yung Q0 natin is magiging 1. Therefore, ang finally SISU shift register, magiging apat na silang 1. Yung kaninang 0 na reset mode sa ating binary number na apat is lahat po sila is nagiging apat na 1. So as makikita po natin sa ating truth table.